Let's continue our analysis on the determinacy of beam and frame structures. So here we have a beam pin support on one side and a guide support on the other side. So what's the reaction force on these beam structures? We can easily find for this pin support, we have two reaction force. For this guide support, so this guide support have freedom to move vertically. So have freedom to move vertically, but this support cannot move horizontally. So then also this support can rotate. So that means on this support they have one reaction force. So in total the reaction force is R equal to 3, and we only have one member, N equal to 1, so then R equal to 3N, so it's a determinate structure. Okay, this is these examples. So then we look at this beam structure as well, so we can easily draw the reaction force on the beam structures. So this pin support, we have two reaction force, this is roller support, and look at here, we have two reaction force on this pin support as well. So in total, the reaction force we need to determine is 5, and the number is 1. So R larger than 3M. So if we can, so what's the determinacy? Is indeterminacy is R minus 3N equal to 5 minus 3 equal to 2. So it's indeterminate structure. Indeterminate structure to the second degree. Okay, so then we move on to look at these structures. So these structures we find as a hinge, so we need to cut the hinge. Then this frame structure is divided into two beam structures. So if we can draw the beam structure, so one is shown here, and the second one is shown here. So this is the beam structure. If you just denote the support A over here, B, C, D. Okay, so look at the support A is the pin support. So pin support we have two reaction force, and at support B we have the roller support, one reaction force. Support C is a hinge. So hinge is, we treat hinge as a pin support. So we have two reaction force. So this is A, B, C. And let's look at C, D. So at support C, so we just look at these two reaction force. We just put these two reaction force over here. And the support D is a pin support, two reaction force. In total, we have 1, 2, 3, 4, 5. And we don't consider these two because this two is equal to the two reaction force on the support C on the beam AC. So we have 5 and then 6, 7. So in total we have R equal to 7. How many members we have? We have 2 members. So R larger than 3N. So if we say R minus 3N is 7 minus 6 equal to 1. So this frame structure is indeterminate structure to the first degree. Okay, let's look at the last one. So the last one is the frame structures. So here we have a very special rigid loop. So when we see this rigid loop, so we need to cut through the frame. So we need to cut the frame structures. Then the frame structure will be look like this. So every time, so this is the frame structure. We need to cut rigid loop. So look at if we say this is support A, this is support C. Support A is a pin support. So pin support will have two reaction force, and support C is a roller support. We have one reaction force. But look at these cutting sections. So on each cut sections we have 3 reaction force need to be determined. So 3 force, So we have 3 force on these 3 as well. Oops. So if we see here 3 reaction force, okay, so this is the unknown force we need to determine. So now let's check how many unknown force we need to determine. So we can see we have 1, 2, 3 reaction force, and also we have three reaction force here, 3 reaction force here, and 3 force here. In total is 9. So we don't need to count the yellow force over here because we already count the right force on the other sections. So then in total is here is 2 plus 9 plus 1. So this is the unknown force we need to determine. So it's equal to 12. And how many members we have? We have 2 members, n equal to 2. So 3n equal to 6. So if we see R meant 3n is 6. So this frame structure is indeterminate structure to the 6th degree. So that's it. That's all the examples to show how to do analysis on the determinacy of beam and frame structures.